My business today. Rules of exponents. Page 194. Take a look at 194 and just kind of follow along on that page. And they're going to kind of walk us through a couple of things. It's basic facts about exponents, basically. How they apply to when you're using integers and how they apply when you're using variables, okay? And what we can do with them. Notice what happens when you multiply two powers with the same base. For example, a to the third times a to the fourth will give you a to the seventh. So essentially what they're saying is a to the fourth times a to the third gives you a to the seventh. May not be as well illustrated with a variable as it would be when we have, let's use actual integers, okay? 2 squared is 4. 2 to the fourth power. 2 to the third power is 8. 2 to the fourth power will be 16, okay? What is 4 times 16? 64, right? Okay. So when we break that down, we say, okay, 4 was 2 to the second power, 16 was 2 to the fourth. What is 64? Two to the sixth power. So what do we do when they had the same base? We essentially just added what their exponents were. So they illustrate that here with the variable. The 4 and the 3 combined to give you 7. Here, the 2 and the 4, when it's all said and done, really means 6. Any questions there? Africa. Well, yeah, it's not prime, but I'm just using it as an illustration to show you that 64 is kind of like one of your base 2 multiples. When you do the prime factorization of 64, all you get is 2 to the 6th power. There's nothing else. There's no other prime factors that go with it. Okay? So it works like that with 2's. It works like that with any that are the same. Look at the bottom of page 194. The first one they give us, 2 to the third times 2 squared is going to equal, following the same principle, 2 to the fifth, because 3 plus 2 equals 5. 8 to the seventh times 8 to the fifth. 8 to the 12th. 5 times 5 squared. Alex? How many 5s are here? 1 plus the 2, 3. We don't write 5 as 5 to the first. It's just 5. Okay. And then 4 to the 6th times 4 to the 4th times 4 to the 3rd. Doozy. Yeah? Not 14th, 13th. Good. Okay. Any questions there on that, how that works? Now, they have to have the same base number. I was only able to add the exponents because they were all the same. They were all 4. Same here, same there, same up there. Okay, but that's the gist of it. Okay. Any questions? Yes.
Can your the exponent ever be a variable? Like
Not usually. Not likely. I mean, it can happen. Don't get me wrong, but for what we're doing today, I don't see that as being an issue. Okay? Okay. We'll use that principle and apply it to multiplication problem. And just like some of the other things that we did when we used integers with the variables, we kept them separate. We worked through the integer part first, and then worked our way through the variable part. So let's look at, I have an integer of 3 and an integer of 5, and I'm multiplying. So 5 times 3 is, and now I have the same base. I have an x times an x squared, which is the, like, x to the first. So I should have x to the third power. That's it. So 2n to the 11th times 6n to the 8th n to the 19th. We did 11 and 8. Two m to the 4th times 7 m to the 5th. Yes. 14 m to the 9th. Give me a break. Two parentheses jammed up right next to each other means what operation? Fine. So I use parentheses instead of dots. Okay, don't freak out. 4 times 5, 20. A times a to the 2nd. And b times b to the 3rd. Ooh. Okay, here, watch. So again, this just still means multiplication. So a 4 times a 5 is 20. A is like a to the what? And a to the 2nd is a to the 3rd. And then b, which is like b to the 1st and b to the 3rd. I'm not taking requests anymore. Now, there's also division. 64 divided by 16. What? Now watch. Watch. What is 64? 2 to the what? 6. 16 is 2 to the 4th. 2, or 4 is 2 to the... Just look at what's up there and try to figure out what happened. Relate the numbers in green to what we used in blue with the exponents. Now, when we multiplied, we added the exponents. Caleb, we subtracted, but we must be just, I got it. We must be careful. Okay, let me show you the long way. So up on top, I have 6 2's, right? 2 to the 6th power. On the bottom, I have 4. Now what I can start doing is I can start canceling out. 2 and a 2. 2 and a 2. 2 and a 2. 2 and a 2 until I have how many left? And are they on the top or are they on the bottom? This is important, Africa. Are they on the top or are they on the bottom? They're on the top, which means I have 2 squared on the top, and what's on the bottom? Careful. 1. I don't use the 1 because I don't need to because it's this way. We still ended up with 2 squared. Let me show you the opposite, okay? Just watch. If we had it reversed, and I went through and I started canceling out, and I still had 2 squared, but my 2 squared was on the bottom. How would I write that to make sure that the 2 squared stayed on the bottom? Because that's where I have more 2's on the bottom. They're right there. Yeah? On where? Okay. And how we would see that is we would see it like this. 2 to the 4th over 2 to the 6th. Again, you look at it, you say, well, where do I have more of the 2's, on the top or on the bottom? Bottom. By how many do I have more on the bottom? Bam. Right? No, it's not. Please, don't. Different doesn't mean complex. And we've been doing this. You just haven't known it. You just haven't seen it that way. Your eyes are just starting to become open. You've been blind for the last... How old are you? 10? You can call me 50. I can call you 10. 6 to the 9th over 6 to the 4th. Again, where do you have more 6's? On the top. You're okay. So I can just subtract 9 minus the 4, and I get 6 to the 5th. If there's more on the top, I can just subtract. Now, it works the same way, okay, even if you would have like a 10 to the 7th over 10 to the 11th. You would say, okay, 7 10s on top, 11 on the bottom. Where do I have more? The bottom. By how many do I have more at the bottom? How many more 10s are at the bottom than at the top, Alex? So I would write what? Where, top or bottom? What goes on top? I need a 1 on top. That keeps it down. That keeps the 10 to the 4th on the bottom. Good? separate. 12 is not divisible by 8. However, if you would see 12 over 8, could you simplify it without making it a mixed number? But can you just simplify the 12 and the 8? Like, what is their GCF? What's the biggest factor that they would have in common? 4. So 12 divided by 4 is the 3 on top. 8 divided by 4 is the 2 on the bottom. Good. Okay, we just simplified it. And I have n to the 5th on top and squared on the bottom. So subtract. Where do I have more n's, on top or on the bottom? Top by how many? So n to the 3rd. It's not that bad, right? Give it a shot. When we do the multiplication of top, 2 times 4, and x to the 6th times x to the 3rd. Well, you multiply them by doing what? Not by multiplying, and we multiply the powers by doing what? Adding. So that's 9, right? And then 24, x to the 5th. 8 and 24, they both have 8 in common, right? So I have 1 8 up top and 3 on the bottom. And I have how many more x's up top than the bottom? Okay? So 1x to the 4th over 3, or just x to the 4th over 3 is fine. The 1, more or less, is a placeholder. Sometimes you absolutely need it. Sometimes you don't. I don't need it up top. Why? Because I already have an x to the 4th up there. It's already holding that place. All right? So you don't necessarily need it.